All right, so we graphed 8 to kind of see what it was going to look like. I did verify what I was saying about if it's negative, like you still draw the angle where it is, but the negative makes it flip like where the actual line is. So when we get the next one, it'll be a negative, but we'll show you what that, looks like. So 10, negative 3, and 17 pi over 10. So we start out with our initial here. Now, approximately, where would 17 pi over 10 be? You can tell me in terms of quadrants if you
2,
want.
3,
4.
4.
Okay, so 10 pi over 10 would be 1 pi, right? So that would be all the way around to here. And then halfway would be 5 pi, so then that means 15 pi would be down here, okay, over 10, and then so 17 pi over 10 would be somewhere down here. So approximately, it's going to be somewhere down here. Obviously not exact, but however, it is negative, okay, so this is my angle of 17 pi over 10. But it's negative, so I'm actually going to... this in the wrong color. Okay. So it's actually going to be here is going to be the 3. Again, not perfect, but close. So the dotted line is where it should fall, but because it's negative, we flip and it's 180 degrees, basically opposite is what that does to it.
So in the end, my 2 was correct, but not for the question you were asking.
Correct. 12, 3, and then 210 degrees. So initial. So 210 degrees would be where? Quadrant 3. I'm going to use the correct color this time. So somewhere down in here. This is positive, so it actually is going to be down here. So there's my 3 for that one. Now 14. Negative 3. They really like 3 apparently.
Yeah.
And 135 degrees.
At least it's not 4 again.
So where is 135 degrees?
Quadrant 2.
Quadrant 2. So that's going to be somewhere in there. Okay. But this is negative. So while it should be, I definitely have this drawn way too, but anyways. So it should be there, but since it's negative, it's actually going to be down here. And so that would be the 3 there. And obviously we want to get our angle as close to, the correct area as possible. So like 135 degrees, Obviously that's something we can easily do, but
It's right there between the 90 and 180.
trying to get it as close as possible to where it should be. I mean, don't draw like, it way over here when it's really, up here kind of thing. But as long as you're in the right general vicinity, that's what I'm looking for. Okay. Use an algebraic method to find the rectangular coordinates of the point with the given polar coordinates. Approximate the exact solution with a calculator when appropriate. So this is where calculator will have to be in the appropriate mode. It looks like for all of them that you're going to need a calculator for, it'll be radian mode, but just make sure you pay attention to that. So 16, we've got 2.5 and 17 pi over 4. Anybody remember our formula for finding x and y? Who is it?
That's Nathan.
Sorry, am I interrupting?
You're okay.
Yes.
I'll be missing all of your classes on Friday.
Okay.
So I'll be leaving after lunch. And then also, I was out at homeroom today because I went food babysitting last time.
Gosh, that's awful. Hold on.
Yeah. I got it from Taco Bell, so use your error, I guess.
I was just telling Kenny yesterday we haven't eaten there in a long time. Maybe I should stay away for a little longer.
Yeah, well, I went to the one in Yorktown by Costa.
I would have trusted that one. Yeah, nope, not that one.
Thanks, guys.
The one by Chick-fil-A in
What
Yorktown.
did you do?
It might. I think it is technically listed as Yorktown. The other side of the street, Burger King's listed as Newport News, but I think Taco Bell is listed as Yorktown.
Oh yeah.
Just because of the way that it cuts off, yeah. Okay, do we remember the formula for this now?
Nope.
So x is r cosine theta. It's really useful. if you
And
have
what's
an
y?
exam.
Oh, that
R sine theta.
Yep, so then just need to plug stuff in. So this is 2.5 cosine of 17 pi over 4. I'll go ahead and do the other one. 2.5 sine of 17 pi over 4. Now, do we know 17 pi over 4 directly?
Well, no.
No, but what can I do?
The that.
Coterminal, or you can just look at your unit circle and keep counting. But let's look at coterminal just as a refresher. So 17 pi over 4 minus, how do we find coterminal?
Subtract.
Which in this case have a common denominator would be what? 8 pi over 4. So that would be 9 pi over 4, which is still too big. So I need to do it again to minus 8 pi over 4. Oh, look at that. Equivalent of pi over 4. So I'm going to rewrite this as 2.5 cosine of pi over 4 just for the sake of looking at it because obviously it's the same thing. What's the cosine of pi over 4? Now, since we have this 2.5 here, probably a good time to get out your calculator, but I would just do 2.5 times root 2 over 2. But if you want to type it in as cosine of pi over 4, that's fine. And then 2.5 times root 2 over 2, again, which those are going to be the same, so that works out nicely, but...
That's
I have a charger up here if you want to plug it in. I'm not sure. I think it's this one. I got it. I think. Yeah.
So,
Pretty
what do
sure
you
it's
want
that
them rounded out to?
It looks like they do too.
Oh, okay. 1.77.
Say it one more time.
1.77.
Okay. All right, so then we need to write it as a coordinate pair, so 1.77, 1.77.
That's nice.
What?
They're the same.
Oh.
That's nice.
It's quiet, that's it. It's quiet. Yeah, you can repeat it for what? It's loud. I saw her. Oh.
They left for elementary ensemble singing. I forgot. That's why.
Oh, that's why Cole went. I was wondering, I was like,
That's funny. All right, 18. -2 and -14 pi over 5. Now, is 14 pi over 5 something we know?
Nope.
Do we know how to find it? Okay. Now, is that going to give us an exact value if we do find it? like a root 3 over 2. No. So I'm just going to plug this one in and just type it in my calculator, but make sure you're in radian mode to do that. So x equals -2 cosine of -14 pi over 5. And y is -2 sine of -14 pi over 5.
I got the y is 1.18.
Does anyone have x?
Riley, do you not have a calculator still?
Nope. We just went through this and it's
Yeah.
not charged.
So x is 1.62.
So we got 1.62 and 1.18.
Virginia, don't you have 2 calculators?
One's probably dead.
One's dead. The blue one. It's always dead.
Oh, well,
Again, I have a charger.
I always forget, and I've used it multiple times.
I also have a charger.
I don't even know where mine is. I should use yours. I don't even know.
What, your charger?
Yeah.
Oh, well,
I lost. The cord was too tiny. I lost it. Wow.
my dad has stolen mine. I don't even know why he does that calculator. Would serve him no purpose.
All right. Are we okay with that?
Yeah.
Okay. So then, the next thing, I'm kind of gonna jump back and forth, a little bit, before we come back to the homework problems, just because there's not a ton of problems in this section, and I feel like we need to see a different one before we do that. So we are gonna be doing, or making 2 polar coordinate pairs that go with the rectangular coordinates that we have. Okay, so basically we're going to be finding 2 polars for 1 rectangular that work. So let's see, the point -1, 1. So that means that x is equal to -1 and y is equal to 1. Obviously, we know that. So, the formula we have is r squared is equal to x squared plus y squared. So, I need to find r, right? Because I have x and y, and r is part of the polar coordinate. So, r squared is equal to -1 squared plus 1 squared. So that's going to be 2. So r is equal to, well, I guess I should say r squared is equal to 2. So what does that mean r is?
Root 2. Plus or minus.
Plus or minus root 2. Now, I want to find my theta. Do we remember what formula to use to find that when I only have y and x? Should be under.
Tangent of theta equals y divided by x.
Yep, tangent of theta equals y over x. So tangent theta equals 1 over -1. So theta equals the inverse tangent of -1. So where's that? And remember, where can tangent only occur?
And like,
The right side.
you know,
So,
You need to go.
Negative pi over 4.
negative pi over 4. Good, you remember that you have to go down instead of telling me that it was 7 pi over 4, as some people tend to do. Okay, now I need, well, a couple different things. When I do this, okay, if I want to get more possible angles, let's say, all I need to do, let me say this, where else is tangent negative 1? Like, what other theta value?
3 pi over
3 pi over 4. So what did I have to do to get from, like, the minus pi over 4 to 3 pi over 4?
4. Add 3 pi over 4? Or
Well, I meant negative pi over 4, and I went to 3 pi over 4.
subtract. Oh, a bit?
can we make the radius negative?
No. Well, I mean, I don't need to. Just mathematically, how do I get from negative
Add
pi over
pi.
4 to 3 pi over 4? Add pi, yes.
Oh, okay.
I
Okay.
was hoping it wasn't. Yeah,
So-
that's-
Every time I add in pi, I get the same value of negative 1, right? Every time I go halfway around for tangent, I have a repeated value, right? So if I add in pi, every increment of that from there on out will give me another spot where the same thing occurs. Okay, so we can do, so basically that's why I said we have, so negative pi over 4 if we had 0 plus 0 pi. Then the next one, if I add 1 pi, would be 3 pi over 4. And I could keep going, so on and so forth, right? But I only need 2 of them. So this is, let's see. What in the world? So we've got, we're going to have 2 values here, 2 polar coordinates that we're going to be dealing with. One is going to be positive root 2, one is going to be negative root 2. Now, the negative one means that what is happening?
It's flipped 180 degrees.
Yeah, it's flipping. So, since this point is opposite of the negative pi over 4 one, I'm going to put the negative pi over 4 here with the negative root 2. And then for the positive one of 3 pi over 4, the angle is positive, and that's around over there. So I'm going to make this one 3 pi over 4. Now, the problems in the book say to find different ones that satisfy different conditions. So one where it's like theta is between 0 and 2 pi, one where it's between negative pi and pi, and one where it's between like 0 and 4 pi. But honestly, we're probably just going to do it this way where you just need to find 2, because I think that that's more realistic to what you're actually going to be asked on the AP exam from what I've seen in there. But so let's look at one where we have either x or y is 0. So let's have the point, we'll just call it Q this time. -3, 0. So that means x is -3, y is 0. So r is equal to -3 squared plus 0 squared. Alright, so it's r squared.
Darn it. Trying to get
So r squared is 9. So then r would be equal to what?
positive. Yeah, just 3
Plus or minus 3, yeah. So then tangent of theta equals y over x. So that's going to be 0 over negative 3. So where is tangent of theta 0? At 0. So at 0, and again, we can add in pi because it's also 0 where? At pi. And we can keep going at 2 pi, at 3 pi, at 4 pi, and so on and so forth. So every time we add pi, we have that. So 0 and pi we'll use for our angles. So at negative 3, 0. Now this is a polar coordinate here, not, obviously it looks exactly the same as this one, but this one's polar. And then also at 3 and pi.
So how do you decide which goes with which? Like, how we have 3 and negative 3, like how do you decide which one is 0 and pi over?
So that part's a little confusing, to be honest, because like this one up here, like to me didn't make any sense as to why. Let me see if this other book has a better explanation for it than our book does. I marked all of this stuff the other day and then I forgot to print it. Let me see.
Can you use the restroom real quick?
Yeah. Because I want to be like, well, it's the one that the first one that's produced is the like first angle that you find, but I'm like, you're finding plus or minus,
Yeah.
so like that doesn't. It's getting into complex numbers, so that's not that. I mean, what the book says is that for this one, they said we use the angles negative pi over 4 and negative pi over 4 plus pi, which is 3 pi over 4, because p is on the ray opposite the terminal side of negative pi over 4. So that point, I guess the initial point that was given to us, is opposite the terminal side of negative pi over 4. So negative pi over 4 would be down in quadrant 4. But this point, negative 1, 1, is actually in quadrant 2. So it says the value of r corresponding to this angle is negative. So to get it from negative pi over 4 to where it needs to be, I guess it has to be negative. And then the other one, 3 pi over 4, would already be in that quadrant, so it would just be positive, is what it's implying, that like 3 pi over 4 already meets that quadrant requirement.
So we just have to have them in the
So you have to look at where would this point be if you plotted it. and then look at the angles that were produced and see which one. And if you need to get it back to that quadrant. So either it needs to be negative or positive based on that, which then, yeah, it's just the way that it's worded is super weird. So then for this one, -3, 0 is to the left, but the angle of 0 would produce the +3. No. Yeah, would produce a +3, but we need it to be on the other side, so it would have to be negative to produce the to flip it over with the graph. And then this one, pi is already where it needs to be, so that one can be positive that way, I think.
Okay.
Does that kind of help?
A little bit.
Okay, we'll look at a couple more and make sure that that's, but the wording of it is weird because they only have that like in the example. It's because like the other reading part of this text is when we use both polar coordinates and Cartesian coordinates are rectangular. The pole is the origin and the polar axis is the positive x-axis, blah, blah, blah. By applying trigonometry, we can find equations that relate the polar coordinates and rectangular coordinates of a point P. But like it never says well, they go back to this here also to find all polar coordinates. So P has the polar coordinates r theta. Any other polar coordinate of P must be of the form r is theta plus 2n pi, which for tangent n pi works, so I'm not sure why they're always doing 2n pi. But then it looks like for the other one, it's 2n plus 1 pi, which is where the pi part is coming from, I guess. But I think the way that I was saying it, where like we see where the original point is and we need to get to that's the terminal side, I think that's what we need to do. But we have a few in the book that we can look at, and we'll make sure that is truly the case here, since they don't do a great job of explaining it, and still been a hot minute for me on some of those. So when we do 27 through 30, I'm going to do them the same way as these, where we're just finding like the two, rather than all the different ones that they're asking for. So, let's see, 28. They give us the point 1, 3. So just for reference for us, since it seems like it's going to make a difference, where is this? Like, where would this point be? Yeah, quadrant 1. So let's just go ahead and note that at the beginning here and see if what we think is happening is what's really happening. All right, so I need to find r, so that's, I keep saying find r, I just need to write the square root on the other side because it's going to keep throwing me off. R squared is equal to 1 squared plus, 3 squared. Second guessing myself on everything. So that's going to be, I was about to say 4, that's awkward. 9 and 1, so 10 is r squared. So r is equal to plus or minus the square root of 10. So then from here, we need to find theta. So tangent of theta is equal to 3 over 1, right? Yeah. So I guess we're going to have to use the calculator for this one. Love that. Oh, yeah, with a calculator when appropriate. There we go. So theta is equal to the inverse tangent of 3, radian mode.
1.25.
like it's going to be easier to think about these when they're in in degree mode, since that's not a number that we just know where that is. Just for us to visualize what that is, let's convert it to degrees. So 1.25 times 180 over pi. Because I need to be able to think about where that angle is, and 1.25 doesn't tell me anything about where that angle is. Okay, so 71.6 degrees, so that would be where?
Quadrant.
So that's in quadrant 1. So that means that our first angle is in quadrant 1. Our point is in quadrant 1. So that means I need the positive square root of 10 for that one, right? Because that's going to put me exactly where I need to be. Okay, so then that would mean that the first point is going to be square root of 10 and 1.25. Then the next one, we would add basically plus in pi for the other one. So if we add pi, I don't know what that is. I know where it's going to put me, which is in quadrant 3, right?
Yeah.
So this is
About
so
4.39.
4.39. Okay. So 4.39. So that is down in quadrant 3, but I need to be in quadrant 1 because that's where the original point was. So that's why I'm going to use the negative root 10 one, so that when I have that angle, it flips it back into quadrant 1. So then this would be negative root 10 and 4.39.
When we're adding plus and pi, like on our calculator, what do we type in? Do we actually just?
Well, so n is just any number. So like for this one, we're just using the first one. So we're just using 1. So really, you're just adding pi.
Okay.
Like the problems in the book are telling you to find it in like 3 different intervals, but the problem is like in this case, every single one of these is in the interval. Like this is in every interval that they gave us.
Mm-hmm.
So I'm gonna look and see how they write their answers, because these ones are the ones that aren't in the front. So I'm gonna check and make sure. What section is this? 6-4. And this is number 28. Oh, okay. I know what they're doing. So this technically answers part A of the question. So part A is going to be what you're answering for 27 through 30 when you do it. We're not doing the other part of it. But basically you're doing the same thing, but you're like having to subtract around until you get there. So anyways, but that's just, if you can do these, you're fine. So, but yes, this is how they leave their answer. They do leave it as to 2 decimal places, just like this. So yeah, so we're good on that. All right, let's do one more. 30. So the point, -1, -2. So where is this? So this one's in quadrant 3. So I just want to make sure that when I'm done that I get everything into quadrant 3. So r squared is equal to -1 squared plus -2 squared. So r is equal to the square root of 1 squared, so 1 plus 4, so square root of 5.
Plus or minus.
Seeing if y'all are paying
Look
attention.
how smart we are.
Had to make sure y'all are paying attention.
So is that just for your cookie points, basically?
Huh?
Is that just for your cookie points, basically?
Pretty much.
Only if we've gotten it. If we hadn't gotten it, then that would just be sad. Yeah.
All right, so then tangent of theta is equal to -2 over -1. Theta equals inverse tangent of 2. So you'll have to find that again. Now, because we knew where this was, right, 1.25, we can pretty safely assume that that's also going to be in quadrant 1, but if not, you could convert that. So that means that the first angle is in quadrant 1, okay, but I need it in quadrant 3, so which one am I going to need to pick for this one? Negative square root of 5. I knew what you meant. So that means the negative square root of 5 and 1.11 are going to be the first one. So then when we do the plus n pi, okay, it's plus pi, then that means that we're going to have what for that one? 4.25. So then that's going to be, we know that puts that in quadrant 3, which is where I want it. So that means that the positive square root of 5 one is that one. And I'll just verify again. Number 30. Yep. And again, this is part A of the problem if you're checking when you go to check your work. The part A answers are what you're finding right now. So, and all that I care about you finding. I think it's a little excessive to have you find it out to 4 pi. Like, I just don't see why that you need to do that. So, let's see. There's like one more thing with this section, plus matching graphs. So I'm going to play with my calculator a little bit and then like before tomorrow, and then we'll wrap this all up tomorrow. But if you want problems for what we've done so far, so that way tomorrow all we have is the actual graphing, because we might get started on 6.5 tomorrow with the like full-on graphing stuff. Problems so far. 1, 5, 7, 9, and 13, and then 17, 19, and then 27 and 29. Now, if you feel like with like these like graphing ones here where you're like drawing where that is and stuff, if you're like feel comfortable with that, you don't need to do all 3 of them or anything. But so yeah, we'll just do the graphing stuff, which kind of leads into 6.5, which is actual graphs of polar coordinates. We'll at least do the notes for 6.5 tomorrow probably, but you should have a little bit of time before we actually jump into that. And then at the earliest Friday we'll quiz, but we may wait till Monday, and then we may start the chapter 9 stuff that we need to look at on Tuesday, Wednesday. You're not here Thursday, is that right?
Of next week? Yeah.
And
Thursday and Friday. I'm not here Friday.
You're just not here Friday. Okay.
There is a chance I might be here Thursday.
That's what Tori said for like half day Thursday
Yeah.
or something. Okay. If you are, then that's if you can make it through anatomy, then you don't have to one less day you have to count off for your exam. But
Exactly.
okay.
That's the plan. So currently I will be here Thursday, not Friday.
Yeah, because Tori's thing said that she was going to be out both days, but she said she might be here for part of the day. So, which is what I figured. That's what I thought you had said as well.